introduce myself, my name is Karl Heinz Froehner. My background is I got a PhD in physics from the Max Planck Institute in Stuttgart. Years ago, I worked in the semiconductor field all my life, microelectronics, in different companies, Bosch, Siemens, Fairchild, Innovators. Eventually, it brought me to Taiwan, and in Taiwan, I actually ran into a person who invented the technology I want to present today, and he actually installed it in the German bakery in Taiwan, where we always happen to be and meet. So I want to introduce today how this what the idea of the technology is and how it works. Is this coming across properly? Okay. And I just don't have the remote control. I have the remote control. I can. Okay. Okay. Our company is Rueste. We are located in Wapengers Falls, at the very eastern end of Wapengers Falls, near the Taconic. And my wife and I actually founded the company in 2005, and since then we developed the technology so we can introduce it into the market. And we call it ECO3TEC, and I try to tell you briefly how this whole concept works. I go through what is ECO3TEC, how it transforms the way we wire buildings or environments, how the system integrates everything into one system, how the neural network architecture looks like, the savings potential, the system components, applications, key features, the wiring example in a typical building and house wiring structure, electrical safety aspects, and then how it affects renovations, industrial applications. I show you some installations and what else we do in terms of partnerships and potential. So the ECO3TEC is an extra low voltage wiring technology, literally for any place electrical controls are needed. The smart technology, it's a smart technology that replaces wasteful wiring in conventional installations. It's a decentralized control that eliminates centralized structures in home runs, like when you have a central controller. We create a neural network that integrates all building disciplines into a single wire control loop. And we actually have multiple parallel systems that run on one communication wire. So instead of having multiple parallel systems, you use only one combined system. It's a very cost-efficient technology that reduces the use of precious metals and energy waste. And it's actually endorsed as a sustainable new building technology by Professor Michael Braungart, who is co-author of Cradle to Cradle, Remaking the Way we make things. What we want to do is actually, we want to change this wasteful typical wiring. When you have a room, for example, where you switch 3 lights from 3 different locations, this is actually what you have to do in terms of wiring to make it work with three-way and four-way switching. And we want to go to a structure where we have very little Romex wiring for high power wiring, and the rest is all thin control wiring running on low power. So what we try to do is, in our technology, is that we, instead of having all these parallel systems installed in buildings with lighting control, safety, security, utilities, motion, climate, and so on, we all try to integrate it into one system running on one control loop. And in terms of wiring, instead of having multiple parallel installations where you always have a controller or a power supply controlling an individual aspect of the building, like security or safety or anything else, we literally try to put all these devices onto a loop on one wire, and we supply the power to where the power is needed, and the rest is all low voltage controls. In terms of savings potential, once you do this, you actually are able to reduce the amount of precious metals you use in installations in buildings by up to 80%. And that is actually calculated by Professor Braungart, and he calculated an example for a typical installation in a German apartment. And the use of copper in cables can be reduced almost by 3/4, because now you wire only very short distances to the power user, and the rest is all control wire. And in terms of carbon footprint, of course, this is somewhere in the range of 3/4. You can reduce the carbon footprint by saving materials and saving energy. And I want to bring one more aspect, which is the energy efficiency. Typically in buildings, somewhere you use less than 60% of the energy is really used efficiently for what it's supposed to be doing. The rest is energy used in controllers, in computers, in devices, on lines. And our system is able, by reducing all these cabling and by dropping the central controls and all the other components, we can actually increase the energy efficiency, and the component which is lost as non-efficient electricity in the building can actually be reduced by a fraction of the conventional installation. Oops. So just two numbers to follow this up. The energy efficiency is calculated by Professor Braungart here to be increased from 53 to 89%, and the use of precious metals in a typical installation goes down from 200 pounds to 42 pounds in this example. So how does the system actually work? The system has very few basic components. And we use 24 volt as a power supply to run the control wire. And then we have literally nothing else than cable to connect all the components, which is typically we use an Ethernet cable, Cat5, Cat6, but literally any cable does. You can use this piece of whatever via telephone, it still works. It's a one-wire bus system. Then we have input devices, which are transmitting devices like keypads. For example, to switch a light or to ring a doorbell. And then we need receiving devices, which are then switching lights. For example, in this case, you just have a receiver and a relay. And on top, you need a programming device. So every transmitter and receiver has a chip card on board. And the chip cards actually get programmed by a handheld programmer, where you tell what this button does when you press it, so where the signal goes, in this case, for example, to this receiver. So this is the minimum installation you do. You have a transmitting device, a receiving device, pieces of cable, 24 volts somewhere, and you need a handheld programmer, and that is your basic system. If you need 50 times more, you buy 50 times more components, more wire, and loop it all together, and you can communicate from any point to any point. No further electronics or no further controllers or anything else. So that means we have all kinds of, we can literally loop all kinds of applications together. I just put a whole bunch together here. For example, you see timers, or you see motion sensors, or any kind of input device. And also integrated functions. We have, for example, so-called smart devices, where we have an onboard receiver, and you can then switch a whole bunch of relays. For example, this would be working for radiant floor heating system. So you would just connect it to one wire, and you can distribute your thermostats on the loop, and you can control all the different zones. And that's just an example. Or you can do this with LEDs too. And this is just an image of my demo here, where we have different application interfaces and switches. So the applications can literally be anything in terms like keypads, motion sensors, security sensors, motor controls, timers, power switching. Anything you can think of, you can actually literally connect and directly communicate. And they are connected via an onboard interface. The whole system is designed to allow any future applications to be integrated or added to the existing neural network without any rewiring or the need of extra software or control interfaces or electronics. So you can just literally buy another motion sensor with a transmitter, find the wire, tee it off, connect it, and tell this thing to switch on the same light you push from a button. And so that creates literally totally flexibility and unlimited ability to upgrade. The key features, just a summary, and then I go into more pictures. This is the first wiring and building an automation system which has a true neural structure, where every point communicates to every point without this organizing computer. So you literally can wire 1,000 points among each other on one wire loop. There's no central control box. We use no computer to control this whole thing. It's all kind of a hard-wired solution, a hard-coded solution. We use no software to program this. It's just the address code. We have no central breakdown points as a consequence, so all the systems are independent. If a keypad fails, the rest doesn't know about it. You just exchange it and replace it. and repair it. We can use uninterrupted power supplies because we have very low power usage in the system. The units work on an average of less than 1 milliamp. So if you have 100 units in a building, it runs on 100 milliamps. We have a one-time cable and wire installation. That means once you install your control loop, you can just continue to add on or modify. And we put away with the multiple wiring for independent systems like communication, motion sensor, security. They can all be hooked onto the same communication wire. So there's no add-on wiring to any central control for additional applications. That's what I just said. When you add or to the system, and let's say in 5 years from now you upgrade, you just add to the system wherever you can find the wire. You tee it off and you add on more components. The system configuration is possible prior, during, and after installation. The wiring installation, as I mentioned before, can be substantially reduced. And the cost of the system is actually a fraction of the cost of traditional systems. When you go to competitors, centrally controlled European Instabus-based systems, they are multiple times more expensive. We have cross-system multifunctionality. We are absolutely child-safe because every interface is 24 volts or less. So that means every human-machine interface is safety extra low voltage. We have ultra-low running costs because the system itself uses very little power. We can service this as a modular service. That means we have hot plug-and-play functionality, essentially. We can very easily integrate low power and energy savings applications down the line. And what I said before, virtually unlimited expandability. It's very easy to install. The training for an electrician with a minimum background takes no longer than half a day, and then know how to set it up and program it. We also can add remote functionality and serviceability, and the system is truly a building, wiring, and energy management system which is affordable for the average income family. And that's actually where it's targeted at. The system is literally a different way of wiring a building without wasting so much material and energy. So let's just go to a simple example where we have a living room where we use all kinds of different controls: lighting, safety, security, intercom, and others. And this is a sketch with 3 doors, 3 lights, and so you try to control the 3 lights from 3 different doors, and then you add intercom functions, and so on and so on. If you do this in a conventional wiring scheme, then you literally have this kind of wiring scheme. And I don't want to go through all the details, and you see that we have to power the lights somewhere from the fuse box. This is all Romex here, and this is 3-way and 4-way switching, and the rest is then fire and security and so on. So let's say you want to switch on light number 2, for example, and this is just an example how the current would flow through all these wires. And of course you would have a second component, which is the alternative switching in a 3-way switching. So these are all the wires which have to be run just to switch one light from 3 different locations. If you do this for 3 lights, then of course it triples. And when you go to our wiring scheme, we only supply the power to the lights directly, and then we have a receiver relay to switch the light. And the rest of the system is all low volt, 24 volt control wire. And since we have a neural structure, we don't need a central controller. That means we have no home runs to anything. That the structure of the system is completely flexible. That means the only rule is you have to connect it somewhere. So you can just add on, wherever you find the wire, you can just add on more applications. And of course, when you, in the same example, if you switch on a light in this case, then the power would only run through the very short Romex run. And to just stay in this picture, just for the power part, this directly compares, of course, then the amount of wire is actually under power when you switch on a single light in a typical conventional installation. Of course, this also means that you create a lot of losses or heat on all these lines which have to be powered, versus in our example, it's just this very short wire where you come into the room to the light and that's it. And a third aspect is this safety aspect. All the interfacing with humans, all the keypads, anything else is all 24 volts, which is actually extra low voltage, or it's actually called separated extra low voltage. And I just want to focus on this aspect here. the way we design everything is that literally this is our control environment, and wherever we switch lights, we actually have either an optocoupler or a relay which has which is designed with a safety barrier. In the US it's 6 millimeter, in Europe it's 8 millimeter code on a board, so that we are, in all cases, the control environment is completely separated from the actual power switching we do. And of course, you could go a step further in the future. If you have, for example, lights, and you would do this with 24-volt LEDs, then you can actually have these lights also in this arena. So you would have a completely extra low voltage environment in your walls. And this system allows to do this very easily. Whether you switch this light here 110 volts or 220 volts or 1000 volts, or it's 24 volts, the only difference with 24 volts at the end is that you can do it within the same box, and you don't have to separate it in a junction box. So it's actually easier, it's actually more cost efficient, and then you can integrate it further. Then you have actually 24-volt LED lights, for example, and you can have the receiver directly in the light, so it's a smart LED light, and you just connect them with one wire, and you can control 1,000 lights on the same loop without any additional infrastructure costs. And just one word about renovations and modifications. If you do renovations, for example, let's say you have a simple 3 lights, 1 switch, and then you want to convert it to 3 lights and 3 switches, then of course you have to add a few switches and wiring. If you do the same thing now, you want to switch it from 3 different locations as I showed it before, then you have to add all these components, not only switches but all these Romex runs, and it can be substantial amounts. It can be hundreds of feet of Romex actually in order to make this workable. And if you want to add another light or another switch, it's literally impossible at that point already, because then you run into cable thicknesses which are practically not feasible in a building. If you do the same with our system, of course you need sorry, I should go back. You need a transmitter and receiver to switch the lights. If you go to 3 lights, you just need more buttons on your keypad, but the wiring is the same, and you just need to be able to individually switch those lights instead of with one relay. If you go to this scenario here, then the only thing you add is actually 2 keypads and a little piece of wire, and they just talk to the other lights. And you can add another 50 of those keypads or locations, and you can add as many lights as you want. The wiring is literally neglectable. So the cost is actually, the more complex the structure gets, the more the savings are actually in terms of renovation, especially in secondary costs. And I just want to briefly mention that I'm always talking about the private home and the wiring in the private home, but this system is so universal in terms of how it switches and how it communicates that there's a whole scenario of industrial applications. And I just want to show you this picture without going into details, that of course you can do very complex switching scenarios without the need of to run through closets, for example, like in industry. Normally, if you want to switch like 10 lights from 10 locations with 10 buttons, you would have to go through some kind of panel and wire this. In our system, you do is decentralized. You have intelligent receiver relays and keep it somewhere, and you have 24 volts, and you link them all on one wire, and that's it. And the wire can be up to 1.5 miles long. So that gives you an enormous possibility. And the same, we have a myriad of scenarios for DIN rail mounted switching, which is standard in the industry, monitoring and control environments, where you can have a power supply and all this stuff on a DIN rail in a closet, and then you switch it from anywhere you want in the building infrastructure, in the building structure. The same with controllers. If you need buttons in a closet, you can just wire them through one wire, and you can literally have up to 1,000 addresses. So you can have 500 buttons controlling 500 things on one wire. Just to give you an example where this was installed so far. In 2004, this was installed in a demo in Germany, and it's actually a demo house where a family lives in. And it was also installed in Taipei in Wendel's Bakery, and that is actually where I saw it, and that is where I met Al Buchner, who is actually the inventor of the system. And it's running since then. It's an installation in Taipei which is equivalent to 5 of those buildings. It's a bakery, bistro, beer garden, and so it's tested, and you see our keypads actually there, right there. And just recently it was installed in Hamburg in a building in Germany, which is actually an energy producing building. They produce 4,500 kilowatt hours a year excess energy in the building. And we also installed it in the Hong Kong Housing Authority last year because they want to use it for their low-income buildings in the future. By the way, I forgot, in Hamburg they use this actually as a training facility, and just next Saturday we'll actually have the senator for building and environment there, and they look at this for projects in the city potentially. So we also put this into a Ensastar in Nanjing. This is their headquarters is wired with the system, and this is a demo wall where you have 21 lights and all kinds of switching scenarios to show it to customers. And the Chinese are actually very interested in this right now for all kinds of major infrastructure projects also, in, for example, train station renovations and other things. So here in the US, the first one we installed was in our own house in Orphangers. And then we did a renovation in Salt Point in 2007 where they have this in the living room. We installed it in the IBW in Harriman in classroom 5 as a demo. We integrated it with 24-volt LED lights there. And then we installed it as a retrofit in the meeting hall. They have 4 groups of light, and they switch it in the back and in the front 2 times. And we put a little panel in the side room. And the only thing the system needs now is the power comes in here and 4 relays and goes out to the ceiling, and the rest is this yellow control wire going to the keypads and to the relays, and that's it. And the 24-volt here, the tiny little $5 power supply. And that's the whole installation. And they took out about 2,000 feet of Romex. In this case, they need 20 amps per circuit, and if you run 20 amps to 200 feet or more long cables, you need gauge 10 or whatever. So they took out an equivalent of more value of Romex than this system cost actually to buy the components. This is just a repeat what I just said. Just in terms of reliability, maybe one word. Since 2004, the system is running without a problem. And in one word about Rueste itself and our partners. So we are developing right now a sales network. We're also developing distribution partners. I'm president and founder, and together with Karen, my wife, and also CTO. Stephen Young joined us as CEO. Marketing Works from Cold Spring is our sales and marketing group. We signed an affiliation agreement with Hudson Valley Center for Innovation in August. And we have regional partners right now with EcoBus in Hong Kong and Taiwan. And they're very strongly supported by the German trade office in China and Taiwan. In Europe, in Hamburg, and there's a lot of activity going on right now, info requests even from the government in Berlin about how the system works. Ensastar in Nanjing, they're pushing ahead right now, and they identified a huge number of projects, and they want to really introduce it in the province and make it a standard for the electrical wiring in the Jiangsu province in Nanjing, which is 80 million people, like the size of Germany. So. And as I said before, the system was endorsed by Professor Braungart. He looked at it a few times, and he's like totally excited. He advises the German and the Dutch governments actually on cradle-to-cradle principles. So. In terms of market potential and expectations, I think this system has an enormous market potential. Not only for new construction, renovation, also historical preservations, industrial control environments. Ships, for example, they're interested in ships. There's a huge ship building facility in Germany. They do the Disney ships. They are interested. Airplanes, we got already requests there. Motor vehicles, literally any scenario where you switch and want to communicate a push-button command from one point to another. Interfacing to smart devices, smart grid devices. I just want to give you more ideas. So our regional partners recognize the savings potential, and they actually act pretty fast right now, especially in Asia. And I think the technology is gaining global recognition, and we are laying the groundwork to get it started here in the US. I think early adoption in Hong Kong and China and Europe actually supports our operations here to get it started and maybe accepted. And of course, I hope also with the help of Hudson Valley Center for Innovation, we can get some more traction. And I think I have one more slide, which is our nice area here 3 years ago. So that's it. Thank you. don't know whether there's time for any questions.
I'll tell you what we'll do. We're going to conclude the meeting, and Karl Heinz is going to be here for Q&A, as will Jay and Joe, and anybody else who'd like to speak to. So I'd just like to say thank you all for coming. I know we ran a little late, but I think this was a very informative session. And thank you all the people online, and we'll see you next month. We have a great speaker lined up. Wonderful human being, humanitarian. What else are you? Just a nice guy. So we'll see you soon. Have a productive day. Take care.